All right, let's talk about how to find the area of a composite figure. For that, we're going to use the examples on page 632 through 634 in your math book. A composite figure is any figure that's made up using two or more geometric shapes. So it has to have at least two shapes, and it doesn't matter what they are. It could be a triangle and a rectangle. It could be a triangle and a circle. It could be a trapezoid and a triangle. It could be a square and a circle. It doesn't matter. The biggest thing is on a composite figure, you have to look at it and divide it up by adding some lines to it, in most cases, to make the shapes that you can work with. That being said, if you look at example 1 on page 632, you can see they've given you a shape that has a 6-meter red line and an 11-meter base. This shape is made up of a semicircle, which is half of a circle, and a triangle. So you'll notice right here, the first thing they did is they figured out what they had to find the area of. Now, we didn't talk about how to find the area of a semicircle because, honestly, it's the same as finding the area of a circle, and then you multiply it by a half, because there you see your formula for the area of a circle, pi r squared. And you see they have a 1/2 in front of it because it's half of a circle. So you can see here that in the area of a semicircle, you need the radius. So they put a 3 here and squared it because they gave you a diameter of 6. Some kids like to take these shapes and draw them as two separate shapes like they did right here. Notice they took the semicircle and drew it here. They took the triangle and drew it here, and they labeled them both accordingly. Now the semicircle and the triangle share the 6-meter measurement. That's why you see it on both shapes. But only the triangle has the 11-meter base. And they plug the numbers in and they do the formula. Now it asked for the area of the entire figure. So you can see here they added their answers together. 14.1 plus 33 gave them 47.1 square meters. And you can write square meters that way with the words, or you can write it as 47. Guess I should have grabbed a pen that worked, with the m squared behind it. Either way means the same thing. All right. The other one they've got worked out here for you is example 2 at the top of page 633. Mini golf holes composed of two trapezoids, or two quadrilaterals. One is a trapezoid, one's a parallelogram. We don't use a lot of trapezoids, to be honest with you. But you can still see they set this up as they have a trapezoid, which is 2 foot on one side, 3 foot on the other side, and it's 3 foot tall. Then they gave you a parallelogram. And the parallelogram has a height of 2.5 feet. It is 6 feet this way. It is 3 feet this way. We do not need the 3-foot measurement on the parallelogram, because in order for us to use the height of any quadrilateral, we have to use the distance that is perpendicular with one of the sides, which is why the 2.5 feet is here. Okay? And you can see they put the numbers into both formulas, they worked them both out, and they added the answers together to get 22.5 square feet. We're going to do example B, and we're going to do it actually on notebook paper, because you should have some notes started using the first part that was already on your page. So you'll want to add these 4 formulas to your notes, because these are the most common shapes you're going to encounter. And I listed them in the order of frequency. You're going to see parallelograms, rectangles, and squares used in composite figures more than a triangle and more than a circle. Trapezoids, you are not going to see that often in real life. All right. We think about a lot of buildings and a lot of like patios or playgrounds. They don't have trapezoids in them. They're made up of 4-sided figures, triangles, or a circle. All right. So that's why I listed them that way. So make sure you get those. So we're going to look here at example number 2, the shed problem. Okay. We have a shed. It is made up of a rectangle which means I'm going to have a formula for base times height. And the rectangle that they have given me measures 12 feet tall and 15 feet wide. They've also given us two triangles. And that's important because you see here we have a right triangle on the left side, and we have a right triangle on the right side. So that's why you'll see I wrote triangles equals 2. That's going to be important at the end. The triangles they gave us, they happen to join together as one big one, and I'm drawing these as best I can. They tell us that it is 4 feet tall, and we know that because the bottom of the triangle is sitting on the top of the rectangle, we know that this full distance is 15 feet. Okay? That means we have to be careful when we get to the triangle. And the area for our triangle is base times height divided by 2. Okay? So now I'm going to just push the book to the side so it's easier for me to write. And we're going to work on solving this composite figure. All right? So we got a rectangle, base times height divided by 2. Base times height. So we know that B is 15, and we know that H is 12 in our rectangle. So we plug them into our formula. And we get the area to be, figure that out while I figure that out. Oops. $180 feet squared, because it's in feet. Okay. I'm going to switch to the triangle. I'm going to do that in a different color. We'll use orange. All right. So a couple things. Remember earlier I said we got to be careful with our triangle because, see, there's two of them here. But this 15 feet represents the whole distance from the tip of one triangle to the tip of the other triangle. So we have to figure out the base of the triangle. All right, we know the height is 4. All right, there's our height. We know our height is 4 feet. But we don't know our base because they put the two triangles together and just told us that together they make 15 feet, which means I need to have half of 15 as the base of the triangle. And half of 15 is 7.5, because 7.5 and 7.5 makes 15 feet. So the base is 7.5. All right. Now, I'm going to go back up here real quick, and I'm going to circle this triangles equals 2 in red. And I'm going to put some exclamation points behind it, because I can't forget that when I get to the end. So here we go. The area of one triangle, base times height. The base is 7.5. The height is 4. We're then going to divide that by 2. 7.5 times 4 is 30. And 30 over 2 is 15 feet squared. But remember, that's for one triangle. And we have 2 triangles. All right? So we have to take our 15 feet squared, and we have to do it one of two ways. We can add another 15 feet squared. Oops. Or we can just double it, and we get the area of 2 triangles, because that's how many we have in the shape, of 30 feet squared. Okay. So now that we have the area of our triangles, and we have the area of our rectangle, we just add them together. 180 feet squared plus 30 feet squared gives us a final area of 210 feet squared. And that is the area of the shed. Okay? And that's all we do. All right. I think we need to make sure we stress on the order in which we do these things. All right. So I'm going to give you those steps next. First, you got to figure out what shapes you're working with. All right. Because if I don't know what shapes I'm working with, like if I didn't know in this example that I was working with a rectangle and a triangle, then I wouldn't know what formulas to use. So I have to be able to divide my shape up into something I can use, or that I know the formulas for their area. All right. The second thing we have to do, once we know our shapes, we have to find their area with the correct formulas, which is why it's so important to be able to look at your shapes and break them up into what they have, or what you have. All right? And the third thing we have to do is add or subtract. All right? And if you look at number 4 on page 634, at the top there, example number 4, you'll see that they've got a problem worked out where you have to find the area of the rectangles and then subtract the areas, because you're not going to fill the entire space with water. All right? They tell you the area of the entire rectangle, the shaded area represents the pool. So the shaded area in this case is the blue space. All right? So they're going to make this funny shaped pool, it looks like. And then our job is area of the entire rectangle. You notice they did 42 times 25 because that's the big rectangle. And then they did the not shaded area, which was the 20 by 22, and they subtracted them because we want the area of the shaded region. And if we find the area of 25 by 42, that gives us everything. All right? So we have to be very careful that we're using the right operation at the very end of the problem. Okay? Your homework assignment will be posted with this video in Google Classroom. And I encourage you to look back at this video. And if you have questions, email me on your homework assignments so I can help you if you need it. All right?